Complex number. As the name says complex, but the topic is extremely easy and the question is extremely easy. If you attend two sessions like this one and the other one, maybe half of the other one, you will able to solve this question completely. There is no other possibility that you cannot solve. Uh, there are some critical point where student usually get confused is at the end as the analytical part, because for the beginning you will apply the properties, you will apply the formula and everything, you will solve it, but at the end you have to analyze it. So that one needs little bit patience and little bit effort, then you are able to solve this question. And I guess if this will be a question in your exam, um, if it is a sub question, like if it is a part of some question, so it will like 4 points, but if itself is a question, it will be 8 points. 32 points. uh, Whenever you didn't understood anything, just stop me, because since it's a very basic one, I'm not writing it. I will focus more on questions rather than just writing and spending time on examples, sorry, on the notes. A complex number could be in a format a plus ib, where we know a and b belongs to a real number, and this we say is the real part of the complex number, and this b is the imaginary part of a complex number. Is it clear? So the real part of the complex number is a and the imaginary part of the complex number is b. uh, when we compare two complex numbers, so z1 and z2 are two complex number, and if you want to say both of them are equal, that means their real part must be equal and the imaginary part must be equal. So the real part of this complex number must be equal to the real part of this complex number. The imaginary part of this complex number must be equal to the imaginary part of this complex number. So in short, if I want to write, if z1 is equals to a1 plus ib1 and z2 is equals to a2 plus ib2, so if z1 is equals to z2, that means a1 is equals to a2 and b1 is equals to b2. Okay. Then some basic operation on complex number. If you want to add two complex number or maybe subtract two complex number, you can just add or subtract the real part, and you can just add and subtract the imaginary part. So I have taken some example. 6 plus 5i addition with 8 plus 3i. So you can add 6 plus 8 plus 5 plus 3 as the imaginary part. You can add the imaginary part together and you can add the real part together. Similarly, for subtraction, you can subtract the real part. You can subtract the real part here and you can subtract the imaginary part here. That's the basic algebraic operation of complex numbers. Coming to multiplication, when you have two complex number and you want to multiply them, so it's simple. A plus b into a plus b, or a1, like it's the same one, no? A1 plus b1 multiply with a2 plus b2. So you can just open the bracket, you can multiply this one over here, and then you can multiply this one on both the terms.
Okay.
So
I didn't understand this part.
just a minute, let me write it out. So I can write a plus c plus id plus bi to c plus id. This one multiplied with this one and this one multiplied with the whole one. So if you have a plus b multiplied with c plus d is a into whole c plus d plus b into c plus d, then is ac ad plus bc bd. Now did you get it? So yeah, that's the same thing I'm doing it over here, but remember one important thing. Whenever you are multiplying, okay, I just open the bracket until here is the same. Now if you multiply IB with ID, you will get I square BD, and I square is -1. As I is iota is root over of -1, so I square will be -1, so there will be a minus sign because of this one. So you see it's I square BD, so I can just write minus sign over here, and this one is, yeah. So why I given more importance to this part? For example, if you have 5 plus 8i, you want to take the square of it, so is a square plus b square plus 2a. So this one will be 25 plus 8 square 64 I square, then you have this one is 40 into 2 80i, right?
Yes, yes.
Then you have this one as 25, this is minus 64 because of this I square plus 80i. So you can just do the algebraic thing and you are done.
Okay.
And there's one more concept, conjugate modulus. So if you have a complex number as a plus ib and you want the conjugate modulus of that complex number, so it's denoted by j modulus or j conjugate. So j conjugate is a minus ib, so you just need to change the sign of the imaginary part.
Okay.
So if you have 5 plus 8i, the conjugate of this one will be 5 minus 8i. If you have -5 -8i, conjugate of this one will be -5 plus 8i. You just need to change the sign of the imaginary part, not the real, but you will not touch it. Then always we use this technique in all the complex number. Whenever you have a complex number in denominator, when you have iota in denominator, we always rationalize it. So rationalizing, you mean whenever you had something in denominator, you used to whenever you have something in denominator like this, we used to multiply this minus this divided by the root over minus this, right? You used to do that for rationalizing. This one also similarly you will do, like if you have something, a complex number in denominator, to rationalize it you have to multiply with the negative real part, this a minus ib. What will happen if you do this? In the numerator you will get a minus ib, but in the denominator the iota will be removed. Did you got it?
Yes.
So this is a very popular method that we always do with all the complex number question whenever we see iota in denominator. For a complex number you can have a graphical view as well. So this is the real part, this is the imaginary part. If you have a complex number as a plus ib, it can be denoted as, this is a and this is b, so it's a plus ib will be at here. Okay, I agree that I'm going very fast because these are just simple concepts. Whenever you have any kind of question, stop me. Till now, do you have any questions?
No.
Even just a small one?
No.
Sure?
It's fine. Yeah.
Okay. An example, determine a. Should I solve? I think if I solve this one, it's much better. No?
Solve it, why not?
Should I solve it over here?
No.
No, it's already solved over here, but I don't want to just show the solutions to you. I want to like solve it.
Okay.
Let me solve it over here in the small one, then I will erase it so you can prefer the original solution over here. It's better? Like, this is a question. You have to determine a which belongs to a real number, and a complex number is given as z equals to iota divided by a plus 1 negative a iota is purely imaginary. So this is a question. You have to find some value of a such that this complex number is purely imaginary. So the meaning of purely imaginary is the real part must be 0. That is purely imaginary. So the tip for this kind of question is, I have written in such a way that even if you read it, you can understand it. So if you see iota in the denominator, rationalize them, as I have said.
What's the meaning of this?
So if you have a iota I in the
Okay.
denominator, rationalize them.
Okay.
So what will happen if you rationalize it? So you had the original function as a plus 1 negative I a, right? This was the real part and this is the imaginary part. So I have to rationalize it. Rationalizing it means multiplying them with the complex conjugate of this one. So it's a plus 1 plus ia divided by a plus 1 plus ia. I have multiplied the complex conjugate of this one and divided it.
Okay.
Okay, then what will happen? You will get a plus 1 multiplied with I, no, this one. Then your I will be multiplied over here as well, so it's I square a divided by a plus 1 square negative I square a square. Okay,
Okay.
and you know I square is negative
Minus
1, so I can remove this one and I can put a plus sign.
Okay.
Here also I can remove this one and I put a negative sign.
Okay.
Then let's simplify it more, so I get ai minus I minus a divided by
A square plus 2 square.
let's not open it, keep it like that. I guess it might be some more helpful. Then you can separate the real part and imaginary part.
It's A2, right?
Sorry, yeah, you are right, it's a square. So if I want to separate the real part and imaginary part, I can write this minus a divided by this function whatever it is, and I can take the I part over here is a minus 1 divided by the function. Like if you want to see in big picture, until now I had just multiplied the I over here, I got until this step, I came up to here, then I can write this one as negative a, the denominator, whatever it is, this is denominator, plus a plus 1 divided by the denominator, and I is over here. So this is my imaginary part and this is my real part. So the question was
Pure imaginary.
purely imaginary, so
Real part is 0.
this thing equal to 0 and this denominator cannot be equal to 0, so a equal to 0.
Okay.
Understood
Yes.
completely?
Yes, but I need to review
Yeah.
it once more.
So as I said, the tip, first you rationalize it. How to rationalize it? Multiplying the complex conjugate. What is a complex conjugate? You have to take the opposite sign of the imaginary part. Then I just open the bracket, I multiplied here, then I separated the real part and imaginary part, and the question was find the value of a such that this complex number is completely imaginary. So I have the real part and I can equate to 0 for purely imaginary. That was the idea of the whole question.
Okay. Understood.
Sure?
Yes.
Okay. Next question. I think it's better. Let me bring one extra notebook. Okay, can I have a pen? I was writing the tab, so I don't have a pen right now. Okay, so exercise is z conjugate square plus 2i z plus 2z square. I can say z equals to x plus iy, where x and y belongs to.
Actually, to solve it, to find z.
Yeah, so always like find the values of z. You can write z equals to x plus iy, and the conjugate of z will be x minus iy, and z square, this one will be x minus iy whole square. Okay, and if you write it is x square plus iy whole square minus 2x iy. I just wrote the formula of a square a minus b whole square minus 2x iy.
Okay, yeah, this is.
Yeah,
Okay.
there was is I square,
okay.
then the I square is -1, so I got this one. Then what else I need? Yeah, I just need this much. Then I substituted everything in the equation. You can see I substitute everything in the equation over here. Like if I write this thing, this one will be x square y square, I write it here, minus 2x iy plus 2i, my z is x plus iy. Then I have 2 times of x minus iy, right, equal to 0. In place of this thing, I just substitute.
This is conjugate of z
Yeah,
to power.
yeah.
So it's.
I just calculated everything outside and I put it in the equation, and
Okay.
then I can say it's x square y square minus 2xyi plus this one will be 2ix, and this one will be negative 2y. Because of I square, it will be negative, and plus 2x minus 2iy equal to 0.
Okay. Yeah.
And bring all the real part to one side and take all the imaginary part to, like, just can you
Okay.
yeah. You
Okay.
okay, we were here, as I said. Now we just need to bring the real parts to one side. So it's x square y square and minus 2y plus 2x. Okay, these are the real part, and the imaginary part is 2xyi plus 2ix. Then you have 2iy equal to 0. That's it. Total we had 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7. Now there is some term is missing.
No, it's 7 actually. 1, 2, 3, 4. Excel.
I made a calculation error. Okay, so yeah, this is x square minus y square 2y plus 2x, and I can take the I common over here, so it's negative 2xy positive 2x negative 2y is equal to 0. Okay, I just took the
Yes.
I common
okay.
outside. Then to solve the equation, you since it's so you have to solve the equation, so your x y square minus 2y plus 2x must be equal to 0, and the imaginary part also must be equal to 0. The real part must be equal to 0 and imaginary part must be equal to 0. Now is the most important case. You have to solve this equation and get those values. As I said in the exam, if this is a question, everyone reach to these steps. Everybody. Then from here, if you are in a hurry mode, for sure you will make mistakes. Even until now in calculus 2 you will have to like solve three questions, square cube to the power 4, uh, and you will get like 5 6 values from those equations, so you have to be very careful while solving it. It's better to be slow and correct
Yeah.
rather than be fast and wrong.
Yeah.
So here I can cancel out these 2's. I can take out common and do it, and here I can see, you can see this is a formula of x. If I take common x minus y, this one you see, this is x square minus y square, right? This is x minus y, x plus y, and if I take 2 common is if I take negative 2 common is x minus, no, if I take 2 common it will be much.
X minus is y x square plus 2x.
No, I'm not doing. Yeah, you can do that as well, but you need a 2 and you have to subtract 2. Better, I'm just taking 2 common over here, so you can. Okay, if I take plus 2 common over here, is x minus y equal to 0. I just took 2 common from this term, so is x minus y equal to 0. And in the second equation, I can write
Okay.
xy plus x minus y equal to 0. Okay,
Okay. Yeah.
then this one, if you take whole common from x minus y, this one will be x plus y plus 2 equal to 0, and this is xy plus x minus y equal to 0. I just take common x minus 1, so if I take out common x minus 1, this is x plus y plus 2 into 1.
Okay.
Okay, then you have two possibilities over here. Either your x minus y equal to 0, or x plus y plus 2 is equals to 0. Then you have the second equation. So if this is the case, your x is equals to y, right? Since x is equals to y, you can substitute uh, uh, x as y, so it's
Minus y squared
minus y square plus
plus
y
y
minus
minus
y
y.
equal to 0. So you get y
0.
square equal to 0, y equal to 0, and x is also equal to 0 since x equals to y. Then solving this part, your x is negative y negative 2. Okay, then you can substitute this one over here, negative y negative 2, y negative y negative
It
2.
has a
That's
minus.
No,
X plus y.
yeah, x plus y equals to 2, so your x equals to minus y minus 2, so
There's a minus behind
yeah,
it.
I just substitute x over here, so I got this expression, and finally you will reach with, yeah, So let me do it. Here you will get y square,
Plus
yeah,
2
plus y square plus
plus
2y
2y
minus
minus
y
y
minus 2 minus y equal to 0. So you can say y square
plus 2y minus 2y
plus 2y
go
minus 2y is gone is equal to 0.
plus minus square root of.
Okay.
Okay, yeah.
All right. Uh, yeah, now you have two more possibilities. From here, your y could be plus root 2 or negative root 2. So write this way: y is equals to root 2, and here y equals to negative root 2. Depending on that, you will have a value for x. So if y equals to positive root 2, your x will be uh, negative root 2 minus 2, and this one will be x equals to positive root 2 minus 2.
Okay.
So always do this kind of things, or else you will be confused in the exam, and if you miss one value, you lose 1 point. So I wrote it very clearly over here, and I got x value and y value. Then you have to write in the iota form, since z equals to x plus iy. So you substitute the value of x and y, you will get it. Never forget this value as well. So there is also one more complex number, z equals to 0 plus 0i. So we got total three values, right? One, z equals to 0 plus 0i, then other one, uh, this one with this one, then this one with the negative one.
You said at the end what we do?
At the end, you have to, since I got x equal to 0, y equal to 0, so z equals to 0 plus 0i. This is one solution. Second solution, I got x equals to root 2 minus 2 and y equals to negative root 2. So z equals to this one, and the other one, the other equation is this one. So I just substitute the value of x and y over there.
Okay, yeah. One more thing here.
Sure.
This equation, why we conclude that these both or these parts must be zero? We're like adding them together.
No, this is for the complex number to be 0. Like a complex number to be 0, the real part of those complex number must be equal to 0, and the imaginary part of the complex number must be equal to 0. You cannot, if there is if there is a plus minus ib, to this thing to be 0, a must be equal to 0, b must be equal to 0.
There's no
Even if
possible.
your a is plus minus I a, it's also not possible to make it 0, because it's a negative part, it's an imaginary part. You cannot subtract it in that way. If you see this one, in, as I have said, if you just a minute, the graphical notation of this one is a plus ib. Imagine that this is a comma a. Imagine that this is a comma a, so this is a plus ia. So this one is, and if you want to cancel it, like if you want to cancel this term, you have to add it with negative a, negative im. So that will lie over here. Then you can cancel it.
Okay.
Yeah. So if a complex number is 0, you have to make the real part must be equal to 0 and the imaginary part must be equal to 0. Then you have to solve those equation, you get the values, for g. Clear?
Sorry, one more thing. If we get the same as a imaginary and in the real part, if you want to cancel it, you should find the opposite of that? It is not the same as this
No, no,
one?
no, it's the same as this one. I just said him in an example, like how complex number works. Like you cannot there is no other that he asks. No, is there any other possibility?
Uh-huh.
So there is no other possibility. Your real part and imaginary part must be equal to 0.
Okay.
This is how the question begins.
Yeah.
What was the question asking?
Solve this equation.
So that this is z.
Z conjugate.
Okay, z conjugate.
Yeah. So
Square plus 2iz plus 2z.
yeah.
And z was equal to this.
Yeah. You have to find Z. Solve means you have to find Z. So I got
Okay.
3 different solutions that is satisfying this one.
And to be able to solve, we used this rule to deduce that
Yeah.
iota will be equal to 0.
Yeah. For everybody, 90% of the students, 95% of students, they can reach here
Yes.
safely.
And over here, iota went to 0. So
No. This part must be equal to 0 and this part must be equal to 0.
So did we solve them differently?
Yeah. You have to solve 2 different equations.
Okay.
Then you have to solve always in this way.
So where's I in? Oh, okay. You just solved this part.
Yeah.
Okay.
As I said, a plus minus ib equal to 0.
Yeah,
That
B
means
is
a must be equal to 0, b must be equal to 0.
Okay.
There's not
And
always a
then-
direct way like doing this.
See, there are several ways to solve equations, but I will only suggest you those ways which is less prone to errors. In this way, you will never miss one, even not even one value. You will always include every single value. If you want to do it in maybe some other way, you can do it, but be careful. It's very easy to make mistakes. If you miss one value, you got -1. If you miss one more value, like 2 points, 3 points, are only for these things to find out the solutions. Okay, if you make mistakes here, maybe something, you will just lose like very few percentage of the point. But if you make mistakes something in concept while solving equation, you just get half of the point, not even half.
Okay, as you said, there are other possibilities. Like
Yeah.
for this one, this is the easiest.
No, every time this is the most easiest one. The
Every
way
time.
you will see until calculus 1, calculus 2, you have to see like when you are dealing with 4 equations at the same time. There is no other better way
Like
to do
a
it.
change of variables.
Sometimes the questions solved in this much pages, and there will be like 3 equation. You have to solve like until 4 pages or maybe 3 pages, because
Okay.
yeah. So be slow, be careful. You don't eliminate any solution. Clear?
Always we can try at the end that does this value satisfy these
You
equations.
can do it, but
Okay. If we like
if
take
you
the-
have free time, so do it.
Okay.
Yeah, but if you do like this way, for sure you will never make any mistakes. Again, you can check it out for sure if you want to be pretty sure about that, if you completed all the questions. Now okay, I'm not writing these things because these are easy things and you have already known this thing in the school, so I'm just solving the questions. But for sure, if there is some important concept, I will write and show it. I want to be bit fast. So modulus, if you want, like the complex number is a plus ib, and a b belongs to r, and if you want the modulus of z is modulus of g is a square plus b square root over. Note, there are many people make mistakes here as well. 5 plus 5 minus 8i, and if you want the modulus, it's 5 square plus 8 square, that is 25 plus 64 root over, it's I think something 89 root over. But why I said people make mistakes, you might get confused. You will take 5 square plus
Minus.
no, you are just Even it's a square, it will be, you
Yeah,
know,
it won't matter.
yeah, it won't matter. If you take 8i,
minus because of this, I mean. I squared is
yeah,
minus 1.
don't do this thing, it's mistakes. So only take the values, like for example, if you have 5 plus
The
8i, it will be 5 square plus 8 square root over, not 5 square plus 8i square. Okay, this is wrong. Yeah, so modulus of a complex number, if you want to have the other meaning of it, the graphical meaning of it is the distance from 0.
Okay.
So this is a square plus b square root over. And as you know, distance is always positive, so it must be greater than or equal to 0. And if your one more second property, I will not prove this thing. If you want the proof, you can check it out in the internet, or maybe you can use some AI tools to get the proof or verification or something. If your if the modulus of the complex number goes to 0, that double implies the complex number is 0. If you are taking the modulus of two complex number that are multiplied, so you can split them out like this. And this is triangle inequality.
It's W.
It's
Yeah.
another complex number. So if you have two complex numbers there, W, so it will be C modulus of this one, you can multiply the modulus of that one. Just the property. Is it clear?
Yes.
Sure?
Yeah, these are the modulus. So
Yeah.
we have a definition for the modulus.
Yeah, so for if you're you can verify it. 5 plus 8i, 6 plus 9i, if you want to take the whole modulus, will be equivalent to you can verify and let me know. Okay, now you will here first multiply, then you will get a complex number, then you will take the square of this thing, then you will equate with this thing. So this is 5 square plus 8 square multiply with 6 square plus 9 square. You can check it
So
out.
after solving this, will we have to re-add the iota?
No. It's a property. Complex the modulus of product of two complex number is same as taking the modulus of each one and multiplying them.
Okay.
It's just
You can check like 5, 6, 8, 9. Correct. It's
no. First you have to open the bracket. You have to get the real part and the complex part. Then you have to check it. So you can check it out at your home. So it's okay, but it's correct. The triangle inequality, if you have the sum of two complex number and you have the modulus, so this one is always less than the modulus of this one plus the modulus of this one. I think in the physics 1, the second chapter, vectors or something, or maybe linear algebra, vector space, you have the proof of this triangle inequality. Okay, but for here we don't need the proof, you can just know it. Okay, then I have also given two more tricks like which will help you to solve the exam questions bit more faster. But anyways, very obvious thing, if you don't remember, it's okay. It's no, you are not required to remember this thing. If it might help you in the exam questions, but yeah, you don't need to remember it. So if you have z multiplied with z conjugate, so this is z modulus square. If you want to prove it, you can do a plus ib multiplying with a minus ib. You will get a square plus b square and z modulus is root over of a square plus b square. If you take the square of this thing, will be a square plus b square.
Yeah.
Okay,
Okay.
got it? Any
Let
question?
me see it more clearly.
Got it?
Okay. Yeah.
Okay, sure. Oh, any question, feel free to
This
ask.
is a
It's
Z
easy.
conjugate.
Sorry?
It's easy, but this is a Z conjugate.
Yeah. So
What are we trying to prove?
actually, I'm wrong. Yeah. So I was just showing you this both the thing as same.
Okay.
So I did LHS and I did RHS. So I took Z equals to A plus IB, and Z conjugate will be A minus IB. If you
Sometimes when you touch it, something disappears.
no, I'm using it. Okay. Okay. So yeah, so our Z was A plus IB, so Z conjugate will be A minus IB. I did the LHS and RHS, I compared the same. Got it?
Yes.
And you know what's the formula of this thing is A square plus B square root over, and if you take the square of this thing is A square plus B square, the
Okay.
modulus. And one more thing, if you are taking if you have a complex number and you are taking the conjugate, modulus is equals to the same as the uh, complex number modulus. For example, if you have z equals to a plus ib and z conjugate is a minus ib, so the modulus of z is a square plus b square root over, and the modulus of z conjugate is also a square plus b square, doesn't matter the sign. Okay.
Yeah, because the negative sign doesn't count.
Yeah.
Doesn't matter for sign.
What was the formula for modulus function? We just take this one. If you want a
Okay,
modulus
I mean
of
that's
a,
the absolute value.
yeah,
Okay.
absolute. Okay. So the absolute value of z is equals to the absolute value of z conjugate. It's valid for every complex number. And yeah, you can also prove this thing. If you take z plus z conjugate will be 2 times of real part of z, and if you take z minus z conjugate, you will get 2 times of I imaginary part of g. You can try it. You can take like 5 plus 8i and you want to add it with 5 minus 8i, so you will get 10, which is the 2 times of the real part, that is equal to 10. Got it? It's a property, and if you add two complex number, one is 5 plus 8i and you're adding with its conjugate, so you will eliminate the real part, imaginary part, and you will left with 2 times of the real part.
2 times like this is this one, right?
Yeah. No, you don't see this one, just see this
Okay.
one. What will happen? You will cancel out this one, you stay 5 plus 5 is 10, and 10 is 2 times of 5, and 5 is the real part of this complex number. So I just
2
proved
times
this.
the real part.
Yeah. And similarly, if you take the subtraction, you will get 2 times of iota imaginary part of g.
Okay.
Okay. Okay, I'm taking a break of 2 minutes, then we can start. You until that you can also take a. Okay, so as you have tried and you verified these things is completely match here, so
Yes, and
the statements are true.
okay, both are true.
Let's do one question, an exam question basically. So the equation is like this: you have a z conjugate, imaginary part of z minus absolute value of z. Uh, Similarly, we can say z equals to x plus iy. Z conjugate will be x minus iy. Z modulus will be okay. Whatever terms were there, I just wrote it for my reference.
Okay.
Okay, is it correct and clear?
Yes, they are
Yeah.
correct.
Make sure I might be wrong, so you have to stop and let me know. Sometimes
So imaginary part of z will just be y.
yeah,
Okay.
not iy.
Okay.
So just substitute this thing. Okay. Okay. I just
Y
took
minus.
Okay, yeah, that's great.
okay. I just took the real part.
Okay, yeah.
Okay, you are checking whether it's correct or wrong.
This.
This?
No, this is not normal. I couldn't understand what happened exactly here.
Okay, there was. Did you understand until here?
Yes.
I just took out I. I took this one here. Then I took I common. So you have minus y square. You have minus y x square
Okay,
plus
okay.
y square. Okay?
Okay, yeah.
Then.
Each part should be equal to 0.
Yes, exactly. Okay. I can take out this minus as well. Let me write it here. So if I take out this minus outside, this will be minus y, and minus 1 if you take that side is nothing. So solve positive. Okay.
If you take minus,
If you take out minus 1 here, this will be minus y again. So there is a 0, so you can take minus 1 to this side.
okay.
Yeah. So
Okay.
if we're calculating exam dates. Okay, I'm doing it over here. It might be more clear. Yeah. So observe the first equation. There might be two possibilities. One, x equal to 0, or y equals to x square plus y square root over. So if x equal to 0, if I substitute x equal to 0 in the second equation, it will be y y plus 0 square y
Okay.
square, that is y, is equal to 0. So it's no.
We did x is equal to 0.
2y square 2.
No, there is a problem. This one should be modulus y because it's y square root of y. It could have also negative value, so it's modulus y. So it's y square. Yeah. Let's keep it like this, no change. Then in this case, if y equals to this one, you have to substitute this one over here.
Wait,
Let's think something else because
Question.
this will be yeah.
so first we did x, this is equal to 0.
No, I just fix one equation, okay? And there is two possibility of this equation. Either this one is x is equal to 0,
Yeah,
or this one equal to 0, then y equals to will be this much.
okay.
Then you substitute the value of this over here in the second equation.
So we'll substitute the value of x and y.
I got x equal to 0,
Yeah.
so I substitute x equal to 0 in this equation. So this is actually this solution or this solution.
Okay.
Then you have to, then I got y equals to x square plus y square root over. If you substitute this one, that will be 2 times of x square y square. Okay, just a minute. It is x square y square. Then this is 2 times of x square y square.
Could square root all of it
Yeah, so
to the
it's
power of 2. Or
2 times of, I can also cancel out 2 because it's 0 over there. So it's just x square plus y square is equal to 0. Right?
You took square.
No, I just multiplied these two terms.
Oh,
Please
okay.
find mistakes. Yeah, actually there is some mistakes. Yeah, that's why we got into some problem. No, it's correct.
So we have to be super slow and
This is
careful while
exactly
solving
true.
this, right?
Yeah, it's correct actually. You know what I did in this case? I fixed this equation. Here I fixed this one, then y equals to this one. And why did I okay, y equals to x square plus y square root over. Okay, so instead of doing this all shitty things, you have this one y plus y, and instead of this I can write y.
Yeah.
3y.
No.
And there is a
No,
y
no,
also.
there's
So it's
y.
y
y? Like,
2y square.
2y to the power of 2.
yeah.
Nice.
Nice.
Yeah.
y is.
So
This is also correct. We have the
Yeah,
sum
correct.
of two.
Yeah, but
okay,
that
I
would
want
be
to
very,
say.
very hectic.
Okay, we have the sum of two positive numbers equal to 0. The only way that we can have this is they are both 0.
both they're both
There
zero.
is
Yeah.
no-
There should be
no.
like x is equal to 0 or
The
y
sum
is
of two
equal-
positive
yeah,
numbers.
you got it. Yeah, I got your idea. Yeah, did you understood what he said?
Yes.
There are two.
The only possibility they both
Both.
of them become
Yeah.
0 is 2. Each of them will be 0.
Yeah, because there is no other possible case. Yeah, you are correct. But since I solved the equation before, so I wanted to think, okay, why I'm not getting the similar result? So yeah, that's why I was
So
more
there-
worried.
This is also an option and a solution.
No, you see, as he said, both of them is equal to 0.
Yeah.
I get 2y square equal to 0, so y equal to 0.
Yeah.
If you substitute over here, you will get x equal to 0.
Yeah.
Same thing. So here I got x equal to 0 and y equal to 0. But here I didn't have any solution yet.
Mm.
So now you focus on this equation. So you will have two possibilities here. One, either y equal to 0 and x is already 0, or you have y plus y modulus is equal to 0 and x equal to 0. Right? You have a into b equal to 0, so either a could be 0 or b could be 0. So when I took y equal to 0 is one other possibility. Here this one is already included in this case, So I can just eliminate this one because this is already included here. Then yeah, for this one you have y plus modulus y equal to 0. Then you will get two more possibilities here. How? You know how modulus absolute value function works?
Plus minus
Yes, it's even the value is positive.
or negative.
There is no change. It will be
Yeah.
2y. If there is negative, it will be 0.
Yeah, so it's basically the same thing. The modulus function works like this. If your x is positive, if your x is positive, so you get x. If your x is negative, you get minus of x.
Okay.
If you take minus of x, again it will be positive. That's the thing. So here you have to check like this. If your y is positive, okay, if your y is positive, this one will be it's getting more complicated. Let me just show the final two line over here. So if your y is positive, is y plus y equal to 0. So is y equal to 0. This is the case which I've already covered, like x equal to 0, y equal to 0. Again we got the same solution. But when y is negative, is y minus y is equal to 0. So you got 0 equal to 0. That means this is always true. 0 equal to 0 is always true. So it's a free variable.
And can you make a solution?
It's a free variable, so z equals to iy, and for this y is less than 0, so you get infinitely many values. So here I got two different z. One is 0 plus 0i, other one I got 0 plus iy. Clear?
Can I look at the solution again?
Yeah, sure.
Oh no, one thing here.
Yeah.
For any y less than 0.
Yeah.
So why this is?
Why this is? Because until here, did you understood?
Yes.
Like we made three cases.
Okay.
Since we have this function, we break it into two more cases. This is 1, this is 2. When in the case number 1 we got y equal to 0, so again we got 0 plus 0i. But when y is negative, since it's a modulus function, you have to put like y minus y equal to 0, so you get 0 equal to 0. So z equals to iy, and y, it could be any value, but since we had assumed here already is y is less than 0.
Oh, okay. That's our first condition.
Yeah. Clear?
Yes.
So this was an exam question as well. You want to see it?
Yes.
Yeah.
Okay.
Is it clear?
Yes.
It's the most easiest question, but most people actually make mistakes there. So it was in calculus 1, it was used to be a gifted question.
Like a free mark.
Bonus.
Damn. Calculus.
But again, now instead of this one, you have ordinary differential equation. It's also like it's a bit long, but it's easy.
Like
Okay.
it's differential equations, which is long for this.
Yeah, that's complicated. Not complicated. It's actually lengthy but easy.
No, not like computing integrals are not always easy.
Yeah, but in the ordinary differential equation, 95% you will have easy integrals. 5% if you have like difficult integrals, you will already study integration at the end of.
We have to like memorize some important integrals from the integral table.
Yeah. So the paper I have sent you, you just take a printout. Whenever you are solving question, just go there and check the integrals. And by practicing a lot of questions, you will always automatically remember. You don't.
Some of them are very similar to each other.
Actually, I have never tried to learn those. I just use them and I get to it.
How did we substitute y equals to x square plus y square in this? Like,
Yeah, you had.
oh, okay, just y over here, yeah.
Yeah, that's
Okay, yeah, my bad, my bad. Okay, and then it's all y this is 0.
we had class at 6, right?
Another class.
I think it class it takes
Okay.
It takes 20 minutes by walking.
really
Yeah.
from your house onto our house.
Yeah,
Good.
because we don't go by station, we go by the bridge, then we go to Hyper.
Oh.
Yeah, we go by that way. So it's pretty
Which subject?
calculus 1.
You're doing calculus 1 as well? You do?
Yeah, he's doing, but in a different batch. He's doing individually, and they're in the group. So they are about to, like after 4 session, they're about to finish.
You're also taking calculus.
No.
No, you're not.
I'm not. I'm gonna focus on linear the
Okay.
3 topics right now.
Okay, one more question. Easy one also. You have to solve this one and draw S. So I'm not solving it in the copy. I'm just referring you how to do it, and for sure it's not difficult. It's easy. So I started with the traditional method. Always when you get this kind of question, what you do, you put x plus iy instead of g, then you try to like make the normal form. Then when I was trying to get the real part and imaginary part, I end up with this big terms, so it's too long. So I said, okay, no, now you have to think something else. Like when you will just put it x plus iy, you are solving, you got like so big formulas.
But in the exam we should solve in this way.
No.
Okay.
Okay, can I say something? The first equation.
Mhm. Yeah,
So we have the inequality from an absolute value. We have like the definition of that. It's between the value and minus. It's like the absolute value is inequality. We
Yeah.
have two different possibilities.
Yeah.
Either it's greater or less than. So
Yeah.
for each of them, we have a definition. It's like
different possibilities.
yeah, you can do the two different possibilities here.
I did it here. Like because of two possibilities, one possibility gave me this equation, and other possibilities gave me this equation.
Okay.
Since this was already covered by these
I mean,
is
first you solving it inside the.
first I took z equals to x plus iy, then I calculated individual terms, then I just put it in the equation, then I got two equation and I solved them.
Okay.
And over here, y is either greater than equal to 0 because of the model.
No, it could be anything. It could be greater than equal to 0, or it could be less than
less
0.
than
So if
0.
it is greater than 0, you don't need to change the sign, and if it is less than 0, it's minus y. So still,
Less than 0.
yeah. Coming back to this, is it clear?
Yes.
So coming back to this question, as we are already solving those questions, I tried to do the same thing over here. I tried x plus I tried to substitute x plus iy instead of z. I took the real part to one side and the imaginary part like this side. Then you had the what is the modulus function. You will need to okay. Then I had given you the trick. Since you have the iota in the denominator, you will try to rationalize it by multiplying the, what do you say this one? Conjugate, complex conjugate. But I end up with a very long equation, so which
Not
can
really.
be solved,
Shortest way.
which also can be solved. You can do it.
Not for that time.
Yeah, not forever. You get like 3 terms and you get the square. It's too much. Okay, the smart way. The conjugate of modulus of this one is equivalent to modulus of this. Okay, then I took this one to that side. I took this one to this side.
Okay.
Yeah.
Then I substitute z equals to x plus iy. Here I put z equals to x plus iy. Okay, so after putting x plus iy, there was a 4. I combined with the real part and I kept the imaginary part at that side. Similarly, I done the same thing over here. So if you take the modulus, you a square plus b square, also here a square plus b square. Then to avoid the square root, I squared both the side. So this must be 3 square 9, and this. Then I got some equation must be greater than this. Then I do it. Then I took everything to that side. I got one equation. I got one inequality as this one. And you see, you have x square y square plus 10x plus 16. When you see this kind of equations, you have you studied about conic sections?
No.
Conic sections, equation of circle,
Yes,
equation
yes.
of ellipse,
Ellipse
and
and
equation
Yes.
of hyperparabola.
yeah.
Yeah. So
I don't remember anything.
that's okay.
Besides that.
Even I don't remember those. The only
Circle I do and
yeah, circle I do the same. Yeah, I remember it. Whenever I see like ellipse equation, I go back and check in internet. So I try to. There is an x square, y square. I'm pretty sure there might be a possible like could be a circle equation or something. So general equation of circle. So it's x minus x naught square plus y minus y naught square is equals to r. If this is in like some point, this is the equation, this is r. So here, do you know the method of completing square method? Like you had x square plus y square plus 10x plus 16 is less than equal to 0. Since there is a x term here, I want to make a whole square so that it will be much easier to see the equation. I want to bring it to this form. You know the formula of a square plus b square equals to a plus b whole square is equals to a square plus b square plus 2ab. Since we had this equation, so I want to make some square over here. Like I want to make a square term over here. You will see what is the benefit. This is x square plus 2ab. So here you will see this one is a combination of 2 into 1 into the b. So if I divided 2, I get 5. That is the b term. So I can I have 16 over here, but I need a term 5 square to get the complete square method. So it's just 25. So how much do you need from 16 to get 25? You need a plus 9, right? So if you can add 1 9 and you can subtract 1 9, you will end up with this case.
So we are reversing this.
Yeah, so then we got like this equation. Then by doing this, adding adding a 9 and subtracting a 9, we got this one 5x plus 5 whole square plus y square minus 9 is less than 0. I took this 9 to this side, so you can see this is x minus x naught, this is y minus y naught square, and y naught is equals to 0 over here, and a negative x naught is equals to minus 5 over here, and this is r square. So r square is 9, so the radius is 3. So I can draw it at the coordinate minus 5 and 0 with a radius 3. And since this is less than symbol, so this is the outer layer and everything is under this thing.
I am 110%
Yeah.
sure this was not taught in the class.
But
No, this is a general thing. They will never
Yeah.
teach it, but obviously if you it's easy.
This thing,
At any point
You're
if you have
right,
any question, just tell me.
the equation of circle, like here, this R2, right?
Yes. Yes. You're
Okay, that's the Now we add and subtract a value to make it like a circle
Yeah,
equation.
since we have a 10x, we don't have any y term, so we don't need to care about y. We just try to make this one, this this term by the completing square method. So if you have any doubt in the completing square method, I strongly suggest you go to YouTube and watch the video. In whole engineering life, you will use this one.
This is the completing the square method, right?
Yeah. So go to YouTube. They will have much better explanation, which like in 15 minutes or 10 minutes they will explain it. But if you want, I can also do it. But a super basic one, you can do it from the
YouTube.
internet. Yeah. Yeah, you just need to see the middle term. It's all about, if you know the formula, you check out this
Right.
term, you check out this term, you divide the term, you have 5 square, you get 5. So it's a square plus b square, so it will be 5 square. We have 16 over here, but we need 25. We need to have 25, so we can add the difference and you can subtract that difference. So the difference is 25 minus 16 is 9, so you can add a 9 and you can subtract a 9. By doing this will help you to get this one. So
And then you have to
yeah, then since this was less than equals to, so this is the solution.
And this is the circle's formula.
Yeah, don't forget to set this part.
We have to show this.
Yeah, this I asked in the question, draw.
Okay.
And my question is that how we add 9 to the 10x?
No, I didn't
Why
add
is it
9 in
25x now? Shouldn't
No,
it
it's
be
not.
25?
2 into 5x. 2 into 5 into x. So I wrote it in a square plus b square plus 2ab.
Okay.
Got it? Any question you can ask me. But for sure, if you have any doubt in completing square method, go to YouTube and do it. But if you have any question in this part, I'm pretty sure he will never ask you to draw anything. He will never ask you to draw a circle or something. But for sure, he can ask at least up to this much, which deals algebra things. He will not go to the calculus things. I don't know. It depends on him.
And in the calculus thing, this was the x coordinate, right?
Yeah,
For the circle.
x. The general equation of a circle is x minus x naught
naught.
square plus y minus y naught square is equals to r square.
Okay.
Shouldn't it be minus 5? Because it here is plus 5. And this is x minus x 0.
Yeah, so x naught is equals to minus 5. Yeah, I wrote it over here.
Yeah.
And how did you draw the circle? With what's the
Yeah,
center?
how do we draw that circle?
What's the center of the circle?
Center is given by this one. So you got x naught is the coordinate as minus 5, y naught is equal to 0. That's the coordinate, minus
What is
5,
the-
0.
These are like.
R is the 9 square, so you have r square, r equals to 3.
So y here is 3. We go 3 credits to the up.
Yeah, 3 to the up, you take the circle.
So it would be like this, like if this is the center, 2, right?
No.
Because the center is
Which is your coordinate? This is x coordinate or y coordinate? This one. This is
0,
your
comma minus.
no. This is your x or y.
This is the y.
How minus 5
Minus
comma
5,
0.
comma 0. Oh, my bad. And minus 5, comma.
That side, I guess. Minus 5. Yeah.
Yes, I am very because of the sun.
No, it's okay. It's okay. It's okay. It's very easy to get confused.
No, because of the sun, it has hit my head.
Yeah.
Minus 5, comma 0.
Can I do
Okay.
another time?
Sure. Use 2 fingers.
Oh.
Do you have any question in this?
Yeah, one thing, the inequality of the circle equation is different with because in circle we don't have inequalities. Here is
I will tell you what is the role of inequality. Let us see. I will explain.
Okay.
How did it become this?
Substitute substitute z equals to x plus iy. There is a 4, so is z minus 4 will be x minus 4 plus iy. So this is the real part and this is the imaginary part.
And then how you just
Okay.
okay. Yeah. So you're substituting x minus iy in z.
Yeah.
So it should be like x plus iy minus 4, but then you just swap it.
Yeah. I always write the real part in one side and imaginary
And this
part.
is the modulus.
Yeah. And you know the modulus formula is a square plus b square
Yeah.
root over. Yeah.
Okay.
How did it disappear? Oh, by
Squaring
two
both
sides.
sides. Yeah.
Okay.
Okay. Yeah. Now his question was. It's a good question actually. Where is the empty space? Okay. Yeah. X square plus y square equals to 9. The the graph of the circle will be this one. Okay, x square plus y square less than equals to 9. It will be this circle, but the solution, all the solution between this will be the part of this one. X square plus y square is greater than equal to 9. This will be this circle, but the
Okay.
solutions
Yeah,
are
okay.
outside.
For this one, the solutions are on this circle.
Yeah, on the line.
Okay.
And if you have inequality, it's
It's
just
the
above.
area. You mean.
Yeah, it's the area.
Okay.
So today we did some exam questions, we did some um, concepts. I have some homeworks like these equations are very easy to solve it. Then we have the next part of this chapter is trigonometric representation. So tomorrow, okay, you remember one thing, we are doing everyday linear algebra.
Yeah.
So this is the first part of complex number is done. Tomorrow is the trigonometric part of the complex number. So go through this note in completely detail,
Yeah.
solve the questions, don't even try to just look it and do it, don't do that. That's a very bad approach. Solve it perfectly in your notebook.
Yeah. I asked yesterday as well for like practice question.